Hello everyone, this is Meghana. In this video, let's discuss about graph searching from subject design and analysis of algorithms. So let's get started. So let's have an introduction to graph searching. At first, we need to know what is meant by graph searching. It is a process of exploring all the vertices in a graph systematically, and their types are undirected graph, directed graph, weighted and unweighted graphs. Why it is so important? It is a fundamental concept in a computer science used in a wide range of applications such as machine learning and network analysis. These there are two types of graph searching methods. The first one is a breadth first search. The breadth first search algorithm is used to search a graph data structure for a node that meets a set of criteria. It starts at the root of a graph and visits all the node at the current depth level before moving on to the nodes at the next depth level. The depth first search algorithm has we have an overview. A graph traversal algorithm that visits all the vertices of a graph in a breadth first order, and their implementation uses a queue data structure to keep track of visited vertices, and the time complexity are with an order of v plus e, where v is the number of vertices and e is the number of edges in a graph. And the main application is on to find a shortest path algorithms, social network analysis, web crawling, and a search engine indexing. The next type is a depth first search. It is an algorithm for traversing or searching tree or a graph data structure. The algorithm starts at the root node, like selecting some arbitrary node as the root node in case of a graph, and explores as far as possible along each branch before backtracking. Extra memory, usually a stack, is needed to keep track of the nodes discovered so far along a specified branch, which helps in backtracking of a graph. A depth first search algorithm has an overview where a graph traversal algorithm that visits all the vertices of a graph in a depth first order, and their implementation uses a stat data structure to keep track of visited vertices, and their time complexity is of order of v plus e, where v is the number of vertices and e is the number of edges in a graph. And their main application is on taxonomy and genealogy analysis, and maze solving, and for data compression and indexing. The applications of graph searching in a real life problems. They mainly used on a network analysis to find the shortest path between two nodes in a network, cluster analysis, centrality measures, etc. And even they're mainly used in a social media analysis, analyze social media networks, identify influencers, or detect groups and communities, etc. And also used in a search engines, web crawlers, page ranking, link analysis, and even in a geographical information systems for route planning, location based services, geocoding. The challenges of graph searching. The main challenge is of a scalability issues. As the size of the graph increases, the time required for searching is also increases. And memory constraints. Storing large graph in a main memory can be challenging and may require specialized data structure. Graph topology. The shape and the topology of a graph can significantly affect the performance of a search algorithm. Optimization techniques for a graph searching. Heuristic search, use of a domain specific heuristic to guide the search process and reduce the search spaces. Parallelization, use of parallel computing to distribute the search process across multiple processes. Machine learning, a use of machine learning algorithms to predict the optimal path or to learn from a past searches and improve performance, which is similar to a backtracking. In conclusion, like for graph searching is a valuable tool where it can help to solve complex real life problems by exploring the underlying structure of a graph, and further researchers explore more advanced techniques such as probabilistic search algorithms, dynamic programming, and hybrid techniques. So that's all about a graph searching, and we had an overview of it. So thank you for watching the video.